Welcome to The Explainer. I'm your host, and today we're tackling the absolute ultimate nightmare for developers. I'm talking about moving AI agents from a flawless local prototype to a robust, fully functioning production system. Look, we have all been there, right? You build something absolutely amazing on your laptop, it's working great, but unleashing it into the real world? Yeah, that is an entirely different beast. So today, we are going to learn exactly how to tame it. Okay, so let's dive right into this. Your agent works perfectly in your dev environment. The logic is tight, the prompts are dialed in just right. But literally the second it faces real live users, bomb. It calls the wrong tools, it starts hallucinating, or worse, it just silently returns garbage results. And the worst part? You have absolutely no idea why. It is so incredibly frustrating. Well, it turns out the root cause of all this frustration is almost always the exact same thing, and this comes straight from Arthur's forward-deployed engineering team. Without visibility into the agent's step-by-step logic, your debugging is pure guesswork. I mean, you can't fix what you can't see, right? Right now, your production AI is essentially operating inside a completely sealed black box. So here's our roadmap to fix your production woes. We'll cover 1. The production reality check. 2. Demystifying the OpenAI API. 3. Why tracing is non-negotiable. 4. 5 essential areas to trace. 5. Avoiding common tracing pitfalls. And 6. Closing the production loop. All right, starting with Section 1, the production reality check. Dev versus the real world. So in development, you're usually just making simple, isolated API calls. It's safe, it's predictable. But production? That is the Wild West. A single user request out there can trigger this massive, tangled chain of branching logic, retrieval operations, and complex tool invocations. These multi-step executions span across multiple services, and frankly, they break really easily. When something goes wrong in a chain that long, finding the exact point of failure is practically impossible unless you have the right tools. Take it from real enterprise cases we've seen from Arthur's teams. The teams who actually map out these complex execution paths, they can investigate specific requests, find the exact moment the agent went off the rails, and actually prove their system is trustworthy to enterprise buyers. Meanwhile, the teams who skip this step, they're forever stuck just showing off really impressive but completely fragile demos. Moving to Section 2, demystifying the OpenAI API. Let's look at how the engine actually works. To understand why these chains break so easily, it helps to think of the OpenAI API kind of like a restaurant. You don't need to own the kitchen, you don't need to employ the chef, and in this analogy, the kitchen and chef are the massive GPU hardware and model weights. You just place your order via a Python API request, and boom, you get your generated text delivered right to your table. Super convenient, right? But here is the catch, and it's a big one. This restaurant is totally stateless. The waiter has complete amnesia. They do not remember your last order. Every single API call is completely independent. So if you want a multi-turn conversation, you have to send the entire interaction history with every single request just to maintain context. If your agent forgets to pass along even one piece of context during a complex tool chain, the model literally loses the plot instantly. Which brings us to Section 3, why tracing is non-negotiable for debugging this black box. Because the API forgets everything instantly, establishing a permanent memory for your system is absolute table stakes. Going back to our restaurant, if a customer complains about their meal, how do you know what actually went wrong? Well, tracing acts as the kitchen's security camera. It gives you a highly structured, step-by-step record of exactly how that output was prepared. It shows you every single LM call, every document retrieved, every decision made. That is how you debug failures precisely. Now, how do we actually trace effectively? You basically have two main standards right now. You've got the standard OTL GenAI conventions, which are official, but, they're still maturing and mostly just offer basic coverage. And then you have the Open Inference standard, which platforms like Arthur use. Open Inference is a game changer. It gives you this incredibly rich semantic hierarchy of reasoning. It captures token counts, costs, and explicit span types for specific tools and RAG retrievers. It gives you the exact, granular detail that production debugging actually demands. Section 4. 5 essential areas to trace, the stuff you absolutely cannot skip. So if we are setting up this security camera, what exactly should it be looking at? Here is your non-negotiable checklist. Number 1, trace the raw LLM calls, capturing the full prompts and completions. 2, every single tool invocation, so you can check inputs, outputs, and latency. 3. Your RAG and retrieval calls. 4. Application metadata, things like user and session IDs. And finally, number 5, your custom branching decision points to validate your specific domain logic. Now pay super close attention to those RAG calls. This is absolutely the most common silent failure in production. Your agent might generate this beautifully worded, super confident response, but it's based on completely wrong context documents. Bad context silently creates bad answers. And honestly, without tracing exactly which documents were or were not pulled, you're never going to spot it. Fortunately, setting all this up isn't some massive engineering headache. With a tool like the Arthur Observability SDK, it's actually incredibly easy. We're talking a simple pip install, importing the library, and running the arthur.instrument function. Just those few lines of code, and you automatically get open inference tracing across over 30 frameworks, whether you're using LangChain, Llama Index, or just OpenAI itself. All right, Section 5, avoiding common tracing pitfalls and mistakes. Of course, these tools only work if you actually use them correctly. First off, do not fall into the trap of only relying on auto-instrumentation. Auto-instrumentation is fantastic for framework operations, but you really need to manually add spans for your agent's totally unique logic. Second, as we just talked about, failing to trace your RAG context is fatal. And finally, if you forget to tag your session IDs using context managers like Arthur.attributes, when a customer complains about a glitch from last Tuesday, trying to find that one specific failed trace is literally going to be like finding a needle in a haystack. Finally, Section 6, closing the production loop, moving beyond basic tracing. Let's look at how all this observation builds into a mature production lifecycle. Because tracing isn't just about staring at logs, it is the absolute bedrock of your entire system. Once you have those traces properly recorded, they become the foundation that lets you safely manage and test new prompt versions without having to redeploy your code. They let you run automated pass-fail continuous evaluations against actual real-world user behavior, and they let you intercept bad behavior with real-time guardrails before the user ever even sees it. You've seen the map now. You know exactly how to take a fragile local prototype and turn it into a robust, traceable production powerhouse by implementing proper visibility. So the only question left for you and your engineering team as you build out these AI agents is this. Are you going to stay forever stuck in demo mode, or are you ready to use tracing and actually ship with confidence? Thanks for joining me on this explainer, and happy building.